Alright, guys, welcome to the second part of the microwave video. So, I did end up putting all this stuff in the soiling box, and we can look at it. We can investigate this stuff, but first, we need to have Sparky. So this is a old Sparky that I found. So we'll just do a little Sparky because it is going to be summer. So do a little Sparky because it is going to be summer. This is the summer Sparky. Whoa, wow, I forgot how powerful this one was. Yeah. Okay. There we have the Sparky. Okay. So yeah, Carrie said that these are Dave would call these comically long. It's just like it is ridiculous. It looks like some kind of a joke thing. But yeah, that was funny. So what we do have here is oh, I wanted to do the Sparky on the can. We'll do that later. Sparky on the can. Okay, so let's just. Okay, there's just some screws and stuff in there. There's not a bracket. Okay, this thing. I'll show you guys the stuff that I got out of it. Let's see here. Okay, yeah, that's just. Okay, so we got one of these little switches. These switches are nice. It's like the door switch thing. They're very clicky. They're very fun to press. You could use this in some kind of any type of situation where you wanted like a lever, like some kind of a garage door to see if something was opened, or like if you had a gerbil or something, or if you had a dog door and you wanted to sense it. Those are good ideas for it. And then this thing I think is it says KSD 201, and I think this is sorry, I'm burping. Oh, Jesus. Okay. Yeah, so I think that this is like if it gets too hot, because here, look at that. There we go. So one of these, I did bring these out here. So this was the one that was in that microwave that we just took apart. This is one from a former microwave. And yeah, it's surprising these are actually kind of expensive if I looked them up on eBay, and you know, I was remarking on that one how clean it was, and it really was, and even this one was a lot cleaner than this one that was from a former one, but this one seems a little bit more heavy duty, the magnetron. So yeah, so okay, yeah, so it has it on there. So I guess if it gets too hot, it will shut it off. So that's what, I mean, it's obvious that that's what's going on there. And so this one was on there. So this you could use. So we got part one, little switch. Part two. There's a name for this, right? A lever. It's got to have a name. It's has some kind of a name. There's so many switches. It's ridiculous. Okay, and then this was the bracket that you can see is on on our, oh, there goes some, we've got man overboard. Okay, all right. Okay, so this one is high voltage capacitor bical, made in Ningbo, China. Is there a date code on here? It seems like there's something that looks like it. Well, it's probably just a year or two ago. Okay, so this is 1 microfarad plus or minus 3%, 50-60 hertz, no PCBs, and that one. And then we have our high voltage here. So you can see that this is hooked up to the, let's get this, these are the cords. Let's just try to get more organized here. Yeah, these cords, try to get more organized. Okay, so yeah, we do have this, and yeah, this goes right, this would go right on there. Or did it, or is it, no. This is for the heater. Yeah, okay, so for the magnetron is a tube, of course, and it has to have the heater, which is accomplished by, if you look at the windings here, there's a primary, there's a high voltage secondary, and then this is the heater one in there. And a lot of people will cut these out, and you can get the really thick gauge. Let me see, I'll go get it. Okay, back. Sorry. Okay, so, yeah, so this is just speaker wire, but what people will do is put this in there. They will cut that out and then go ahead and you still use the primary and then have it so you can have a very high current, low voltage thing, and you can you don't want to say solder, 'cause it's not soldering, it's I don't know what they call it. What do they call it? You guys can comment down below. What is it called when you use the low voltage, high current thing to? It's not soldering. It's not welding. It's not really popular because it's kind of like a DIY thing. But of course, it's used maybe in manufacturing and stuff, because it's so clean. It's so clean, and it really just uses the current to connect metal pieces. You can kind of, you know what? Okay, on batteries, if you remember the batteries, like the NiCad batteries, or if you take apart like the little phone that has the it'll have like some, not double A, but like sub A units in it, and then the way they join it is they'll have like I'm not like, well, this is not important. Okay, you know what I'm talking about. Yeah. Um, well, they'll just have like the tin there, and then you can see that it was kind of welded, but it wasn't welded. It wasn't soldered. It was something like that, using the high current to. So yeah, you could put that in there, and wind that around and take out the high voltage. I like the high voltage. And then here's another one. So what? In case you're curious, what gauge is this? Okay, this is 4 gauge. That's 4 gauge, and then this is. Does this say 10 gauge? Okay, so 10 gauge. So you could do something a little different in with the 10 gauge. You could like experiment with it. And then what else did we get out of it? So there's the platter motor thing, and maybe we could see if this will work. Because I do have the. It's probably not. Oh, jeez. Oh my God, I don't want to see. I should be more. So, like, okay, you can tell how. Darn it, this thing is on there. Okay, I don't want to break it. Ow. Okay, these things are not. These are not made by Boeing. Okay, I'm just kidding. Okay, so I do have some power. So what? You're not supposed to do this, of course, but what we could test it out. Yeah, this is not approved of. This is not what you're supposed to do. Just taking off the cord. But we got to make. It's for science, and I have my rubber sole, big rubber sole shoes on, and I have this is double a circuit breaker with a circuit breaker. Yeah, you shouldn't do this. You shouldn't do this. But I do have these gloves. So I do have these gloves on. So look, it's like a thick rubber thing, and then this. I couldn't find the matching one, of course. Like my socks never match. Look, but these are probably not approved for any type of high voltage work. But it has a very generous thing, a very generous plastic there. So we can just go ahead and, let's see, we can go ahead and see, well, let's just see if we get, let's just test the voltage here in the old apartment. So, yeah, this is, I feel good about this. Probably should clear this off a little bit better, but let's just go ahead and AC. Okay, so yeah, you don't want to do that, but okay, 124 point. Well, it's not helping you guys. Yeah. I know you're thinking like, why are you not in your other area? And the other area is like, this was actually like kind of clean. So, okay, so let's make sure this works good. Okay. Why is there still 1.7 volts AC in it when I turn it off? It's the free energy, you guys. It's the free energy. That's weird. I hope my meter. That's why I should probably have 2 meters. Okay. So we could just see if this little thing works. I should probably just hook up alligator clips to it. Well, there's a light too. Oh, I'd hate to walk away from you guys twice in one video. Okay, so we'll. I wanted to test it. Okay. See, usually it has a thing on the side. Well, what I know we could do. We could at least see what the resistance is maybe in this. So this is like an AC thing. This is for the platter. So this rotates really slowly. But let's see if we get. Okay, the resistance on in here. I'm trying to move it, and you can't. You know you can't move it without maybe pliers or something. But it's 3K. 3K on that. See? Oh wow, you can move it. Okay. So as I move it, the resistance goes down. This would be a good generator. I bet this would be a really good generator if you had a crank on there. Yeah, okay, let's just switch it to the voltage and see what. Okay, I'll leave it on the AC voltage. Oh, it'd be easier if you guys could see it too. Yeah. Okay, so it is too hard to do, so we'll just use these and just see. Like, this is probably not the failure part of the microwave. Well, we would need a rectifier and stuff, but I left it on the AC, but it would be making DC pulses. So yeah, so this is a nice little, how many revolutions do we think we got on that? And then here's our other thing. And now this, I have two other, okay, got this off. Two other ones of these. And what's not so spectacular about it is like this wire is very nice. So I have two, this is the third one of these. And that wire is very valuable, I think. You could make a motor windings with it. You could make a Tesla coil secondary with it. You could use it for transformers or use it for, it's just, it was free, they're throwing it away. And then here we have the fuse, a capacitor, an inductor, a film capacitor, and an R1, which is I'm guessing this is really low, and it looks like a half watt. It looks like a half watt resistor, and it's green, brown, and then the color, was it yellow? Yellow. And it's gold. The tolerance is gold on that. Wow. Okay, and then the capacitor is 0.1 microfarad, 250 volts. And it doesn't say, oh, it is, oh, that is AC. It has the little squiggle. Okay, so yeah, so it comes in there, and then what are these, if I can see those are definitely capacitors, okay. It looks like 2222M. I have a magnifying glass. Actually, it's right there. Look, I only have to walk away that far from you guys. Look, you can still see me. I'm still here. I'm still here. I'm still here. I'm still here. Okay. I have to get better at that, or edit it. Okay. Let me just see if I can see that a little bit better. What that says on there. It's probably just your standard. Wow, it's just kind of written on the area where it is shiny, so it's not doing a great job there. Whatever, it's just probably like a 500 volt, 222, whatever that is. What is that? 20 picofarads, or no, 200. No, I think it's okay. I could test it. I could just test the damn thing. Okay, yeah. I'm just need to know. We need to know, you guys. Okay, but it's probably just 200 or 220 picofarads, right? So we're thinking. I know it's in the circuit, so it's not cooperating very well. We can take it out of the circuit by the jaws of life. There we go. The jaws of life. Just okay. You use the jaws of life there to okay, you guys. Okay, like I just want to see what this says. Okay. Well, so you'll know. Yes. Okay, so it's 2.180 nanofarad. So the 222 on it it's probably supposed, it's a little under. It's cool in here. It's not been energized in a while. It's a little underperforming. It's a little underperforming there. But I'm guessing it's supposed to be 2.2. Okay, we don't need to get ridiculously testing all this stuff. Okay, but yeah, so yeah, I want to also show you on the magnetron. We can do this one. So where are our connections on here? Where are our connections on here? We do have the heater here, and then we have this metal base, and then this top part. So 1, 2, 3, 4. 4 possible connections. And but they could also tie 2 things together. So I was thinking that let's just go to resistance. And I'll show you guys resistance. Damn it. Okay, back to resistance. Okay, so now on the heater part, we got yeah. Okay, yeah. 0.1 ohms on that heater part. But now, if we connect it to the base and the top emitter, look at that. That's nothing. Wait, it wants to do something. What is it doing? How could it be 0 ohms? Okay, there, 0.1. It's under what this meter can measure. Look, it's flashing back and forth between 0.1. So there. Okay, yeah. So that's the. I'm guessing this is the ground, and then that's the positive. You got to turn the heater on. So I think the heater needs like 6 volts, 3 amps. I'm just guessing here. And then this will need 4,000 volts DC. And I was thinking of making some kind of pulsing thing, not a total on high current thing out of it, not something totally like that. So that's why that's for another project. But now let's look at this stuff here. So then we also do have the high voltage diode to make the DC for the microwave. And the heater current, of course, is not really rectified. Oh my gosh, we got more of these things. But the gloves are helping. See, I peeled the wire. Well, there's no good way to do that, and it's okay. It just peeled the. Those are nice. It has like a little cloth stuff on it. Okay, so yeah, the heater, it doesn't matter. Just like in vacuum tubes, the heater is. Well, no, wait. Is the heater sometimes? Well, the heater is a lot of times it's DC. I guess it doesn't. It does matter. It would matter. So in this, because they're not rectifying. They're not rectifying. There would have to be another diode there. So they're using AC. They're using AC on that heater, but on most, you guys know, on most vacuum tubes, which I got one right here. I have to go. Sorry, went away from you. Sorry, went away from you. So on most of these, though, it's DC on the heater. Okay, all right, yeah, we all know that. We all know that. Okay. Okay, so yeah, so these are actually kind of expensive, but we could test. Can we test that? I like the construction of this. This is so. So to test that, we can see the diode thing. Select the diode thing. Okay, you guys, like, I'd be a great teacher when I select the diode thing. Yeah, that's great. Okay, so what we're gonna do is put the we'll see if this works. I doubt this was the failing part. I think it's usually the transformer. I said that before. I think it's usually the transformer in this. Okay, so it's with the black on the cathode. With the black on the cathode, this is what we're getting. Now I'm going to reverse it. And we have the positive on the cathode. Oh, maybe this diode is... What? Maybe that's what happened to this microwave, you guys. Maybe that's what happened to this microwave. It was a diode that went. Wow. Okay, so that means that the transformer is probably good, because in some of them, the ones I've got before, some of the transformers are, I have several of them, as you've seen in some other videos, but with those broken transformers, that's when you can go ahead and experiment and do some of this stuff with it, right? So that means this transformer is probably good. Oh, that makes me very happy. That makes me very happy. Okay, so here, like, let's just move along a little. Oh my God, 28 minutes. I'm sorry, you guys. I'm sorry. 28 minutes. Oh my God. Okay. Here's another light, and here's another one of those clicky switches that I call clicky switches. Okay, let's get this crap off of here. Yeah, so maybe this transformer is good, which would be really nice. Okay, we do have our high voltage probe. We do have the high voltage probe there. So let's see if we can declutter here. Yeah, so some nice wires there. This slow motor, and maybe a possible broken diode. 2 of those. And then this heat sensing switch, and then a capacitor, and then we have another one from our other. I probably have about 5 of these, and then this is the next one of this. So Yeah, I'm amassing a nice bunch of stuff that my boyfriend does not is like, why are you bringing all this stuff in here? I mean, it's like you can build something out of it. You can. Are we just gonna throw it away? You know, I mean, maybe I could sell it eventually, or build something, a project out of it. Okay, so here we're looking at the. Here we got this. Let's do a visual inspection of this. I'm so tempted to just get the scale out and weigh this. Okay, I'll be right back. Okay. I'm sorry, you guys, I gotta get some better. I gotta get a better, I'm sorry. I gotta get a better way of doing things. Okay, so here's the scale. I kind of want to just weigh this. We did have a food scale. Why won't you turn on? I think this is one of those fancy scales that. Here, we're gonna weigh it. I want you guys to witness. Okay, this. Does it say how many watts are on this? Sometimes they have like a. Okay, let's put it on there. Let's see. Oh, it's not liking it. It's one of those fancy scales. It's not liking this. See, it's too fancy. It's too fancy, and it's, oh, that's so annoying. So it's one of those fancy scales that wants is trying to conduct, like, figure out my feet conductance and figure out my body fat. That is so annoying. Okay, I'm sorry. Okay, so you'd think you can just put it on there, but the scale is too fancy. It wants a human on there. Why would people be buying the scale and weighing this? Okay, whatever. You know how much these weigh. It's a lot of iron in there. Okay, so visually inspecting. I'm getting too distracted. Looks very nice. This was from the microwave that was very clean. It's just very clean. You could eat off this. I'm just kidding. Okay, so yeah, so I probably just want to take out the heater thing. There's the high voltage thing. So this is the heater wire. This is the heater part there. This comes off of the high voltage, and then there's our two for the primary. And then you can see on here they have the part of the secondary grounded to this. So I don't know if the primary is isolated. I mean, it's isolated so much. I think it is. The primary is not connected to this, to the housing, but the secondary is. But of course, this is high voltage, so it will easily rip right through there if it came down to it. If there was some kind of short, it would go ahead and it would rip right. It would just arc and just start smoking and stuff. But we can. I think we should just. I'd like to test this. Okay, so first what we could do is just test the this. Okay, let's just get it a little bit better. It's like one day I'll move on from the tablet because the tablet, I mean, it's not the ideal way to do these videos, but okay, so we do have, yeah, Okay, so on the primary we have 0.5. 0.5 is solid 0.5. It's not moving at all. Solid 0.5 on that. And then let's just go ahead and test the secondary. So, like I said, we have it right there on the housing or the iron core. Let's try to get better names for stuff. The iron core. And then can I access that? Oh, 136.5. You guys can't. This meter, why won't you behave? Okay, can you see this a little bit better? Let's see that again. So there's 136.5. I'm reading it backwards. 134.5. Okay, yeah. Wow. This transformer, it probably was the diode. So, yeah, I mean, that would make your microwave not work. Because I did plug it in before I took it apart. I did plug it in, and the electronics, the light worked in it. The electronics worked on the timer part. So that's probably what it is. There you go. This little part breaks, and you got to throw your microwave away. That's sad. I got a bunch of those. I got several of those, actually. Well, you can buy this off Amazon, or Temu, or Alibaba, or eBay. Or you used to be able to go to your local, you used to have, well, I mean, Radio Shack wouldn't have that, but, they have the TV fixer things, and they probably would have something similar to that. But they don't want you inside there, they don't want you fixing it. We'll have Lewis Rossman blow a gasket there. They don't want you fixing your stuff. Just throw it away. That's the whole thing of consumerism. Just throw the stuff away. Throw it all away. Yeah, I'm not going to go off on a rant. You guys already, I know how you feel about it. Like, why throw the stuff away? Okay, so how could we... Okay, so I was not fully prepared for this. But I think we should test this. I think... Okay, so for this we got that. So I don't want to be holding this, of course. So what we're going to need to do is, if you want to hang in there, I think since we've made it so far and we're just down to this, I will get, not supposed to do this, but put this in there, connect that, and then we got the ground here. So we're just dangerously close to testing this, and I have my, so put that on there, and then we need to put this in there. Like my scientific, I just want to break this little stupid plastic thing off of there. And then I have 2 bar outlets hooked up, and I have these gloves on. So I'm just going to hook it all up. Oh, Jesus. I'm just going to... Okay, you guys hang in there. Okay. Okay, we're so close. Okay, there. Look, it popped off. Okay, there's our high voltage. There's this. Okay, and we can go ahead and this will be AC. Oh, crap. If we want to make the video longer, we could try to put that diode in and see if... Damn it, now this thing won't... What the... Okay. Let me go get some alligator clips. I'm sorry, this is the 3rd time I'm walking away. Sorry, you can just speed it up. Wait, I'll be right back. I'm trying to think where the alligator clips are so I, get them fast. I should have been more prepared, but I didn't think we'd get to this. I thought we're just going to... Okay. Okay. All right. So sorry about that. Sorry about that. So as I was leaving the other area, I did grab another one of these. So on here, this is interesting because on all of these that I see, it has just one diode. But this one, did I just like put that on there? Maybe it didn't come. Yeah, I think I just connected that. Yeah, I was going to say this one had two diodes on it. So this diode is 5 kilovolts, 0.8 amps. And they have it housed in this, but I'm guessing it's the same thing like that, which is the same thing as that. So, yeah. Yeah, I put it on there. I see, that's why you gotta always know what you're doing. Like, remember what you're doing, because I was like, I've never seen a microwave with two diodes in it. It always just has the one. And so all these things are connectable, and I have a bunch of, so I must have just connected that. Okay. Focus. Okay, so I will, this is not how you're supposed to, did my meter go off? No, I think it was on. Okay, you're not supposed to do it this way. You're supposed to have the dim bulb, you're supposed to have a buddy, you're supposed to have a UL approved thing. You're not supposed to take the microwave apart. You're not supposed to do any of this stuff. You're not supposed to do that. Big Clive does make a good point that he says a lot of people are using these microwave transformers for burning art, and the neon transformers are way lower voltage, still lethal, but like this is could be the electric chair thing, so the neon transformers, especially if you had a small neon sign, it would probably be way better than it's easier to come across the microwave transformers, and the neon ones are usually more expensive, but how much is your life worth? How much, if you're going to be doing the burning wood art, how much is your life worth? Okay, so nothing's plugged in, so we do have the high voltage probe up to that. This is really so you just want, obviously any of that you don't want anywhere near. Oh, this is so annoying. Okay, so I just need to have it. I guess I could just do this as long as it's, nothing's hooked up yet, but let's just go ahead and there. Wow, that's good. That's really good. That's brilliant. Yeah, that's really brilliant. Okay. Oh my gosh, you guys. Okay, we're gonna get to the conclusion of this, and then we'll do Sparky again, and then we'll call it a day. Okay, so we got it on AC. Let's see if that's correct. That's correct. Got it on AC, and then I'm gonna hook it up and then turn on the thing. You guys can see the meter. We got this hooked up. Let's just put these. I'm gonna get far away from it and then turn it on, and then. Okay, so that's there. Don't move. Yeah, it looks, so we got the line voltage going onto the primary with alligator clips. Not the best thing, but we are far away, and it's probably shouldn't be doing it on a metal surface. These are the heater cords. They're tucked away. That is the high voltage. So the high voltage is going there. That's lethal. So what I'm going to do is, this is off, this is on. So I'm going to double turn it off. Okay, so that bar outlet's off. This one's off. and then we'll put it on, and then turn this one on, and then now we'll turn this one on. Oh my god, you could hear that shit. Oh my god, you could hear that shit. Oh. Oops, not good, not good. Not good. Okay, it's off. Alright, it's off and then unplugged. Yeah. Okay, so what happened was... Okay, did we get a reading on that? Sorry, you guys. Yeah. See, this is what you not... This is why you don't want to do that. Those alligator clips were not enough. It could not support the current that the transformer was drawing. So there you go. There's. I'm not going to call it a fail. We did get a reading on that, but yeah, if you're going to be testing that, yeah. Okay, so there you go. It's all unplugged. It's all off. Got fire extinguisher. Yeah. So those alligator clips probably. That's. Why didn't I think that that would be the failure part? Yeah, of course, that wouldn't make sense. Because we had that, those were two small alligator clips. You know, the insulation's on it, and you think there's more in there, but they're just for hooking up little things. Okay, yeah. So we do have that on there. We'll do a better test. This is just a preliminary test. You always want to make sure you're careful with everything. Everything's unplugged. But yeah. Okay, so yeah, this is how you do things. You could do them better if you had a garage, and but you just want to make sure you're very isolated from it. You don't want to do it. Don't do it. Don't do it. Don't do it. Don't take apart the microwave. Don't do anything in this video. It's not a good idea. Okay. All right. Thanks for watching. You guys are awesome.